Good afternoon and welcome to our 6th Data Camp session, Python coding for SAS programmers. A few administrative announcements before we get started. Please remember to stay muted with your camera turned off to minimize distractions. Also, please use the Zoom chat to ask any questions or submit your thoughts. At the end of that session, the questions will be answered by our speakers, and any unanswered questions or ones that need more clarification will also be published in our Q&A section of our Confluence page after the session is over. This session is going to be presented by Derek Cruikshank. I'm going to turn things over to him now, and he's going to give us a little bit more information on himself and then our session as well. Thank you.
Yeah. Hello again. Yeah, Derek Cruikshank. I'm a chief data engineer on the QDAS team. I've actually been coding in SAS since 2009. I've, got all of those handy dandy certificates with base programming, advanced programming, as well as some of the more statistical stuff, and business analyst stuff. But I've also been slowly learning Python the last handful of years. So being able to kind of look at it from a SAS perspective and how Python works, I think can really help me provide a little bit of an insight into kind of, showing and understanding exactly how it might work on the SAS side. And for SAS programmers who don't really know much about Python, it can really kind of help link that, bridge that gap into how you do that on the Python side. So next slide, we can talk about what we're going to go over here. Basically, we're going to kind of go through, what the different types of pandas libraries there are, what pandas data frames are. Also, we talked in our last one more specifically around Spark, utilizing Spark with large data. But I'm going to demonstrate basically how you can do certain things within SAS and how that exact same thing can be done on the Python side. Gonna walk through some demonstrations on some SAS programs that we had developed previously for deliverables and how we converted them to Python. And finally, I'm actually going to walk through an example of how we can replicate what SAS does incredibly well regarding by-row processing. For those a little bit more advanced users, this is specifically around the first dot, last dot capabilities and different types of lag functions that you can utilize within SAS and how it processes data by row, one at a time to the PDV. Next slide. One thing I do want to call out, there's lots of really good information and resources online. I've got it listed in my notebook that will be shared with everybody regarding Python, specifically around SAS programmers and SAS users. But this book I bought a little while back, and it was incredibly helpful as far as, looking at it from a SAS user's perspective and how Python actually works. So those who are interested in it, certainly I would highly recommend looking into that. I'm sure there's lots of online things specifically to it, but it's really more around managing data and not quite as much into some of the actual data analytics and data science. Although I did read that they were going to be coming out with something more specifically within that realm later on. But it's definitely a very good book for SAS users who want to learn more about Python and how to utilize it. So with that, I can go ahead and share my screen and we can walk through the differences of how this works. Okay. So I've laid out a lot of different stuff here, specifically within Python. A lot of what we're going to focus on and what we focused on previously was around data frames. Essentially, a Python data frame is exactly what you would expect a SAS data set to be. How it is processed and interpreted is a bit different. than how SAS processes and interprets SAS data sets, but there is the same capabilities and functionalities. And especially when you're talking about utilizing a PySpark data frame, it's going to be much, much faster than anything on the SAS side when it comes to processing really large amounts of data because of the distributive nature of Spark and these Spark compute clusters that we are running on within Databricks. So get started. I just want to show each one of these in the command lines. I do have SAS code here. I can walk through and show exactly how things are being done on the SAS side, but I do have that exact same SAS code commented out above each of these different command windows in order to show kind of from the SAS perspective of how you might do it, and then what it looks like from the Python perspective. So the first thing I want to talk about is actually importing data. And so from SAS, you'll notice here, you're importing data from your workbench. What is the workbench? The workbench is simply a mounted location that maps directly back to an S3 bucket on AWS. So one thing I do want to point out, you can see here, I've got this member states CSV file located on my SAS workbench. We have a macro. It's %S3_location. By simply running this macro, it's going to output the mapped value of what your workspace, workbench, all of that stuff maps back to on the S3 side. So this is a very, very easy way for SAS users to be able to know, okay, I've got this file on my workbench. Where is that located in regards to S3 from a Python perspective? Because Python is going to read it directly in from S3. So you can see here, I've got this S3 location member states.csv file, and that's exactly what I'm showing here that we are loading into. What I'm showing here is also that we're simply loading it into two different types of data frames. We discussed both of them previously. One is a PySpark data frame. The other one is going to be a PySpark.pandas data frame, also referred to as Pandas API on PySpark. Be able to, exactly follow along on how I'm doing it on the SAS side. You can use a CSV, importing it as a data step with the in-file statement, where you're simply calling out the formats, or you can go ahead and use, an import procedure telling it, your DBMS is going to be a CSV file, and you're outputting it the same SAS data set. Then what you can do is obviously a proc print. You want to view the data is equals 10, just going to print the first 10 observations. You can exact same side on the Python side. Here is how you do it with a PySpark data frame. And again, here's how you're doing it with the Spark Pandas data frame. You're using the show function versus a head function. It's a little bit of differences between the syntax and the functionality of a PySpark data frame versus what Pandas, and particularly Spark Pandas, has to offer here. But it's going to be the exact same thing that we're looking at between Python and SAS. Exporting. When we're exporting a SAS data set, it's just a simple export procedure. Your SAS data set name, the out file is going to, again, be the location on your mapped workbench, what you want to name the CSV. The replace option here is just going to say if it already exists, it's going to overwrite it with the new data. This is the exact same way that we're doing it within the PySpark Pandas side. Again, I talked about in the previous one about this dbutils.fs functionality, where it's really just serving as a file system capability. Because with Spark, it does have the distributive nature. If your data frame is large enough, it's going to output the CSV you want it to into multiple CSV files. This code snippet here that we're going to make sure is made available to everybody in all the user community, as well as having documentation around it and what it's doing. Essentially, this is going to be able to package all of those CSV files that Spark may have written out to your S3 bucket It's going to combine them into a single CSV. It's going to rename it and move it so that it's got proper name that you're expecting it to be onto your actual workbench. So here you can see I want to export this out, and it's going to be called member states Spark Pandas. And so by simply executing this, it will write it out as a CSV, some modified manipulations, and that member states Spark Pandas CSV is now available on the S3, which we can see on the SAS side utilizing our workbench. And the testing folder. Where we now have member states Spark Pandas.csv. Next, we're going to talk about how we can import data from an API call. Wouldn't really call it an API call. On the SAS side, it would definitely be an API call. On the Python side, it's really we're utilizing Pandas and Spark Pandas to be able to go out to this GitHub directory in this particular CSV file, and we're going to import this CSV file into a Pandas data frame. And then from there, I'm actually converting the Pandas data frame into a Spark Pandas data frame so that we can use the distributive nature of the Spark compute, and things will run and be much faster due to that distributive nature. So on the actual SAS side of things, you may already know there is an HTTP procedure where you can go out and use an API call to get data and then import that data into an actual SAS data set. Here, it's a lot simpler. Here, we're simply using read CSV from the Pandas package to the location of where the CSV is located online. And then again, like I mentioned, we're going to convert it. And then we're going to take a little bit, essentially what's going to be the contents of the data set, and we're going to output that and take a look at what it looks like. On the SAS side, again, I do have this code where we can bring this in with an API call, and we're running a contents procedure, looking at the number of observations of our SAS data set, number of variables. And then you can see here, you've got your list of variables, what they were brought in as, it's regarding formats and types within to your SAS data set itself. On the other side, something froze here, 1 second. Okay. On the other side, you can see we've got the same printing the shape of our data frame, which is essentially the number of observations and the number of columns. And then we're printing the info of our data frame, which is essentially just basically the schema, right? So it's listing out the number of columns and what their data type is. So you can see here, it brought in everything as integers and a couple of things as objects. And then it also tells you whether or not the number of observations that are non-null or missing. How we can print the top 15 observations of this data set. We can utilize what's referred to as this head call, and then just simply put in 15 as the number of observations, and it's going to print out 15 observations within our data frame. One thing to note that is significantly different with Python is that everything within Python begins starting at value of 0. SAS will show you a value of 1. With Python, if you want the first observation, the first column, you actually call out a 0 number rather than a 1. So that's something to take a note of and to think about when you're working through things on the Python side compared to SAS. Here, again, printing out top 15 number of observations of the SAS data set. And then if you want the bottom 15, it's a lot simpler on the Python side here. It's a tail 15. That's going to print you the 15 bottom observations of your data frame versus on the SAS side. I'm sure a lot of you are familiar with the first obs equals option, but we've got to take the number of observations, subtract 15 from it, and then we want to start our data set, reading our data set at that number of observations so that it can print only the bottom 15 observations within our output. But that is, again, how you can view your data, top observations, bottom observations, however you want to look through it. I did mention a little bit about this on the previous one, but some of our summary statistics. A lot of people very familiar with the means procedure on the Pandas, Spark Pandas, Python side. It's actually just a describe function. We want to call out specifically what fields we want to take a look at. It's going to automatically give you the count, your mean, your standard deviation, and then it's going to give you min, max, basically essentially your quintiles of those numeric values. We can replicate this exact same functionality on the means procedure. You've got your vars statement where we're calling out the same columns. And then we're just calling out the exact same summary statistics that we're wanting to output it with. And it's going to show exact same output here, variable, your count, mean, standard deviation. Obviously, this is a bit transposed compared to this other one, but it's essentially the exact same output. Maybe you want to plot the distribution. So you want a specific field where you want to plot a histogram of it. Certainly, a univariate procedure is one of many ways you can do this on the SAS side, where you output the histogram of the sex of the driver. So now you can see the way that it's going to plot it is simply looking at the values 1, 2, or 3. I believe 1 is male, 2 is female, 3 is missing value. So what we're seeing is males get into a lot more car accidents in the UK than females. Doing this, we are using the actual plot method that is built in to the Pandas package. And then we're just simply calling the histogram. The way that it works on the Python side is it's actually going to create what are referred to as bins within the values. And this is easily adaptable so that you can create more or less bins based on how many bins, the actual output you're wanting to see. There's a little bit of a difference within the Python side versus SAS. SAS, it's going to just give you all of the actual values on your x-axis, whereas Python is going to take those values, it's going to bin them together. Again, you can see here the values essentially are just a value of 1. You've got your count, value of 2. Again, it's got your count, and then the value of 3. What this is basically showing you is that the bin is a value between 1 and 1.4. And then, so it's basically just showing you the values of 1. But again, it's very, very similar within what we're trying to accomplish with producing a histogram. Regarding distributions on categorical variables, again, I did show this a little bit in the previous one, in how you can maybe even come up with, looping through one variable at a time. But for this purpose, I'm going to go ahead and just show simply proc freak on the speed limit on the SAS side, which is going to output your count, your percent, your cumulative count, and your cumulative percent on all of the different values of speed limit. This is going to be done the exact same way on the Python side. Here, we do utilize another common package within Python referred to as NumPy. This works very well with arrays and works very well with Pandas, as well as it does work with PySpark, a Pandas package. But what we're doing here is we're outputting all of the unique values and their counts within our speed limit column. We're then taking each of the values and putting it out as the frequency. And then we are calculating our percentage using the values over the sum of the values. Here we're using this sum function. And then you'll see the cumulative frequency. We have the ability to, Python has this cum sum functionality, where it will cumulatively sum up all of the values across each of the different values of our variable of our column that we're looking at. And then again, our cumulative percentage, where we're using the cum sum function and then summing the total values. So again, here, the output is showing you the exact same of what a frequency procedure in SAS would output, where we've got our frequency count, our percentages, and then our cumulative frequency and percentages. Now, to get into some specific SAS code that we've converted, this is going to show us a little bit of how we can utilize Python, specifically what's referred to as Spark SQL, to extract from the CDR and put into a Python or a Spark data frame and be able to do different things within it. Again, this is the SAS code where we're creating macro variables. We're simply creating %let statements to create those macro variables. We've got what a lot of you, I'm sure, have done by extracting data from the CDR and bringing it into a SAS data set. Here you can see we're using the quality measures HQR chart abstraction, where essentially we're taking sepsis measures and we're going to sum the numerator and denominator values by the providers for a specific time period. How that's done in SAS here is exactly how we're seeing it. It's a select statement where we're filtering and then we're grouping by different fields because we're summing numerators and denominators. This is done the exact same way on the Spark SQL side. Here we're setting actual just regular Python variables, and they can be treated just like a SAS macro variable. We're running Spark SQL here, and it's the exact same select statement we have above, where we're selecting exact same fields. Here you can see where we're calling those variables, much like we're calling the macro variable within our filters. We're calling them here. And there's a few different ways on how you can do this that I'll walk through to be able to call these specific variables, much like you would call a SAS macro. But you can also see here, in order to put these onto a separate line to kind of make it clean, and so it's not all just one jumbled mess of a single line across, I'm including these backslashes so that it follows Python syntax and what you need to be doing. But again, here, just like a regular SAS macro calls, we're calling these variables and then simply outputting the row count. And here is this dot format functionality where we're passing each of these parameters, passing the variables that we created. Again, this is one way that you can pass variables into a specific string, much like you would pass macro variable. There's F strings as well that I'll get into a little bit, but I wanted to show a couple of different options. And then what we're going to do here is we're going to take a count function on our actual Spark data frame, and we're going to show the number of observations that we got within our data frame, which is the 15,479. On the SAS side, again, basically doing what we did here, where we're going to count the number of observations within our SAS data set and print it to the log. Although we already do have the SAS log automatically does print the number of observations that you're writing to the SAS data set, 15,479. But again, here, it's very similar to what we're doing on the Python side, where we're printing to our log row count is 15,479. The next piece here is, again, we're pulling hospital demographic information. So we want to know a lot of different things about hospitals. We've got this large SQL query that we're passing. And again, what we're doing here is we are using the select data set where we're going to go out to the CDR pass this query, it's going to process on the Databricks cluster and return back a SAS data set with everything that we wanted of hospital information. And then we're also going to do a sort procedure here, and we're going to get rid of duplicate values using a no dupe key option. And how this is done is very, very similar on the Python side. You'll see here, I do have this macro variable I'm creating called end-date. This is going to basically be a way that you can roll specific things within SAS itself. If you wanted to schedule this so that it automatically rolls and calculates the first day of last month, so that you can make sure what you're pulling is rolling automatically, and you can just set it up to run on the scheduler. You can do the exact same thing on the Python side. We're importing a date time package. And the first thing we're going to do, much like what we did here, right, using the today function and then the intnx, where we're subtracting 1 month from today and setting it at the very beginning of the month, we're doing the same thing here. We're taking the today function and we are setting it equal to today, and then using a time delta functionality where we will subtract a month back from the current day. And so how you can see this output is going to be very similar. 23-10-01, 2023-10-01. And we can pass that variable and date within our call, within our select statement, just like we did within SAS SQL statement. And here you can see I'm actually using this F string. So what is this? How is this different? And basically what this is doing is it allows you to pass the variable directly so that you don't need this dot format and then setting the actual variable value to pass within the actual string itself. Instead, it's just F and then your string. And then within the actual string, like I said, we're passing the variable that we created up here in order to extract it. Again, here, we're dropping duplicates just like we did, where I want to drop duplicate hospital IDs. And then it's going to basically show me the number of observations and the count columns within my data frame before I remove duplicates and then after I remove duplicates. So by executing this, we can see on the SAS side, we initially had 72,277 observations. We removed 5 duplicate observations and ultimately ended up with 72,272 and 11 variables. So on the Python side, we've got the same 72,277 with 12 columns, ultimately dropped 5 observations as we've got the 72,272 rows and 11 columns after we dedupe. Now what I want to do is merge my measure data with my hospital demographic information data. I'm going to filter it where I only want to keep rural hospitals or critical access hospitals. And then I'm going to create some binary flags. If it's a critical access hospital, it's going, this field is going to be created with a 1, otherwise it's a 0. With rural, it's going to be a 1, otherwise it's a 0. And then we're going to run a frequency procedure to take a look at the cross-tabulation, see how many hospitals are critical access versus rural, and how many are both. So again, on the SAS side, like I just mentioned, we're going to join it using a SQL procedure. Also, you can sort the data sets, use a data step merge, and ultimately it's going to get you the same thing that you're going to want. And it's going to output this cross-tabulation of CA in rural count. On the Python side, here is the same thing. We are joining our hospital information data, it's deduped, with our sepsis measure data. We're joining it on hospital ID, provider ID. We're doing a left join So we're keeping every observation from the hospital data. And then we're going to go ahead and filter, again, where it's either a critical access hospital or a rural hospital. And then we're also going to create two new binary fields, a CA and rural, where if it is a CA, we're setting it equal to a 1, otherwise a 0. If it's rural, a 1, otherwise a 0. And then at the end of it, we are going to do this cross-tab function of the two fields to ultimately show us, again, the cross-tabulation of how many hospitals were either critical access or rural within our filtered data frame. We can see here there were 12,767 rules that weren't CA, and then CA was also kind of distributed across rural. Some were not, some were. And you can see here the exact same cross-tabulation table where we can see some of the critical access hospitals, which is on the row side, were distributed across rural hospitals, which is on your column side. Next here, we're going to write all this stuff back to the CDR. We're going to filter out only hospitals that are critical access, only hospitals that are rural, and then we're going to write them back to a table within the CDR. So the first thing here, you'll see we're dropping the tables. If they exist, I'm creating a Databricks library statement in order to write out exactly what I want to write out as far as a CA only and a rural only going into my DAS-E simplicity Hive schema. And I do realize on the SAS side, right now, we do have a little bit of some performance issues when it comes to writing large amounts of data from SAS into Hive. Going through that, we're currently working through how we can resolve that issue going around it, and we're going to be implementing that with lots of documentation and help as far as how you can utilize it so that it's much faster than the way it's performing now. How I'm going to do it on the Python side is pretty simple. I'm going to create a new data frame where I'm filtering it to be only critical access. And then I'm going to write that data frame, save as table to my DAS-E simplicity, and I'm going to overwrite it if it already exists. Again, here, I'm just simply going to show row count and the column counts of each of the CA and rural filtered data frames. And you can see here, obviously on the Databricks Python side, this is going to run significantly faster than what it's going to run on the SAS side to the performance issues. But also because it has the ability with all of these data frames being Spark data frames, and it's distributing all of this processing and spinning up as many worker nodes as it needs in order to make it all processed in parallel compared to what we're used to on the Hadoop side, where SAS would process it simply one cluster at a time. So you can see here, we had 2,545 observations written, and then we've got 14,254 written on the rural side, 2,545 on the critical access, 14,254 on the rural side. So we want to perform some QA checks. We're simply going to take a look at counts of hospitals, distinct counts of hospitals, making sure we don't have any duplicates, taking a look at the min, max, and the mean of the numerator and of the denominator. So on the SAS side, we can simply run this using a SQL procedure, and it's going to output us exactly what we want to see. You can see here some of these hospitals don't have any measures because they were open, but they never submitted measures for the sepsis measure. But we can also see here, your sort of checks and balances of, if you will. Here's how we're doing it on the Python side. Again, this is using all PySpark SQL functions where we're importing count, distinct counts, min, max, median, the round function, and we're simply using a group by statement. aggregated each of these different specific calculations that we want to aggregate it by, counting hospitals, counting distinct hospitals, mins, max, mean averages. And then at the end of it, we're going to order it in our output, show that what we are producing is the exact same thing that we produced on the SAS side, where you've got null values, and then everything else is the exact same. 793, 705, 649, all there. So last piece, and I'm going to get through this, is how can we do by row processing? And by row processing, what do I mean? I mean, let's say we're trying to calculate based on claims data if a beneficiary was readmitted within a certain amount of time of an initial admission. So we're ordering this Hive table by all of these different field values and creating, all of these lag functions that are basically taking the value that's in front of them and assigning it to that current value so that you can organize beneficiaries that have multiple claims to determine how many days was in between each of those specific claims that occurred. Were they admitted? Yes or no? Were they discharged? Yes or no? With the discharge from the initial claim, were they readmitted within 30 days and how that all works, right? So doing a lot of this is exactly what SAS does. By row processing, if first dot, lag functions, this is what SAS is very good at doing. I ran this on the Embari side because currently, as we know, there's performance issues with the SAS to Databricks connection. I'm not even going to run this right now because it takes too long to run on the Embari side. But I do have the log saved, and I can tell you exactly how long it took if I can find where I'm at. So executing this on the Embari side took a little bit over 23 minutes. And of course, this was using an implicit connection where I'm reading a Hive table, bringing it into SAS, a SAS data set in memory, doing all of the processing on the SAS server, and then ultimately writing that in-memory final output data back to a new Hive table. How we're doing this on the Python side is by utilizing Spark SQL window functions. For those of you who aren't really familiar with window functions, it's a way to be able to partition and order a specific data frame by certain types of fields. And what you're going to see here is that we've got the ability to break this out and essentially create an if first dot value. So what we do on the SAS side, if it was the first claim of the MBI, we're setting all of these flags and fields, right? And then after that, we're having it calculate whether or not it was transferred in or out. Were they admitted? Were they discharged? Did they readmit within 30 days of being discharged? All of that's being calculated. It's exactly the same thing that we're doing here. We're simply creating all of these new fields and identifying, is this the first initial partition of the MBI? Meaning, is it the first claim of our beneficiary? If it is, then we're setting it equal to null. If it's not, then we're setting a lag value of the previous field, just like it's doing up here. The lag of the from date is being set as the next admission date. That's exactly what we're doing here. The next admission date is being set equal to missing if it's the first claim for that MBI. After that, it's being set equal to the lag value of that from date. We're doing that multiple times to create all of these different new fields. And we're basically setting it equal to the lag value or to missing if it's the first initial indicator. So now we're going to go in and we're going to calculate whether or not they transferred in or out. So here you can see we're calculating the number of days in between the discharge and the next admission to determine whether or not they transferred out to another hospital, or if they did not transfer out, whether or not it's the same hospital or not. From here, you can see exactly the same thing that we're doing. We're creating a new field called transfer out, and we're determining if the days is equal to 0 that we calculated, then transfer out set to 1, which is the first of our if statement. Also, if the days is 1 and the new hospital is not equal to the next hospital, then we're going to say it transferred out. Same thing here. When days is equal to 1 and the new hospital is not equal to the next hospital, it's a 1. Otherwise, they did not transfer out. And that's exactly what we're doing here. Exactly what we're doing with whether or not they were admitted, if they were discharged, based on the same exact logic that we used on the SAS side. And you can see here, ultimately, we're writing this Spark data frame back to our Hive table in the CDR. It took me 8.5 minutes to execute this on the Python side versus our 23.5 minutes on the SAS side. And that was using old Hadoop SAS access connector. So we want to make sure it's the same, right? Of course, we're going to want to make sure it's the same based on what we did. Here, I've thrown together a QA check macro where it's going to loop through, and it's going to take a look at every value of the fields we created and the frequency that we calculated from that value. So here we're executing this where it loops through one at a time, and it's going to output us the distributions of those values. And here I've already done it where I listed the fields again. This is in what's referred to in Python as a list, where it's going to simply loop through one value in this list at a time. So for X in fields equaling to this list, it's going to go in, it's going to group by X, which is going to be whatever value is it's on in the list, and then it's going to count it, and it's calling it frequency. And then I want to print it. And I'm not even sure if I want this to run, but I do have the distributions where you can see transfer out, yes, was 846815. And again, we're getting the same exact transfer out values. Were they admitted or not, discharged or not, and ultimately, were they unplanned readmission? 4834636. 4834636. So essentially what we did here, utilizing Spark SQL and the ability to do window functions within Spark, we were able to replicate exactly what's being done with bi-row processing and how you can utilize lag functions and all of that stuff that SAS is incredibly good at and known for due to the nature of how it reads all of the data one row at a time into that PDV and how it can apply all of these things by row and naturally assign and create all of this logic and flags and different things. And we were able to do it a fraction of the time. So with that, I want to make sure we get time for questions of any kind. But that's really what I have hand out.
Hey, Derek, do you want to continue screen sharing for questions in case you need to loop back and show anything?
Yeah, that'd be fine.
Okay, that sounds good. So our first question, can we share the underlying reasons for Pandas Spark data frame being less performant than Spark data frame?
Pandas Spark versus Spark, yes. Spark is always a Spark data frame is always going to be faster than a Pandas Spark data frame, and that's because even though it's utilizing the Spark distribution on the compute, it still utilizes some of the actual Pandas functionality and how Pandas was basically derived from the NumPy package and how it takes it and it really looks at it more from a multiple dimension array, essentially a matrix, if you will. And so there's still certain functionalities and features that Pandas relies on the data being specifically like not as distributed. So Spark Pandas does distribute the data. It doesn't distribute it as efficiently as a true Spark data frame distributes it, if that makes any sense.
Okay, thanks, Derek. Is there anything equivalent to SAS dictionary tables in Python to find details about multiple tables in a schema?
Yeah, there is. Off of the top of my head, I do not have the answer to it, but I know for a fact that there are. The ability, much like you saw here, there is a column object within the data frame itself that you can utilize to be able to determine what the names of the columns are. I got to find it really quick here. When I read in, 1 second. Where did it go? Row count. Yes, right here. So this columns object utilizing on the actual data frame itself has a lot more functionality to it. So you can basically look at what different columns, like what different columns there actually are within the data frame itself. So if we wanted to actually print them, right, you could use info.columns. And this is going to print it out. And the way that it's going to print it out is to show you it's already put into this this string. Not string, my goodness, I'm sorry. It's been a long day. It's already put into this functionality that allows a list functionality that allows you to do a lot of different operations onto it. So as you see here, when I looked at specific list of fields, right, that I wanted to pass within the list, I could easily utilize that column attribute as well as a DB type attribute to be able to say, okay, I want to list out all of the columns that I know are of some sort of string or object type. And then I want to put in, and so you don't even have to manually do this. This can automatically roll, essentially, where you would automatically come up with a list of every single string or object column within your data frame, if that makes sense, due to the ability that you can use not just that column functionality here, but it also has there's a D type functionality as well, where I'm not sure off the top of my head. Again, I'm still a bit of a Python Google programmer, if you will, but it's certainly stuff that you can find and identify, and I have no idea if this is going to work or not. Of course, it's not. So there is ability to be able to extract the actual data type of all of the columns within your data frame, and then filter that type of data, and then filter only those columns, much like you would within your dictionary on the SAS side.
Okay, thanks, Derek. And then let's do one more question before we wrap today. This one says more of a general Databricks question, but is there a functionality that writes something akin to SAS log to a SAS log to S3?
Yes.
And then this one's actually 2 parts. So I don't know if you want the second part now, but does the functionality of sending emails within code exist in Databricks?
Yes. You can send emails within Databricks. Off the top of my head, I don't know, but I'm sure for it you can make API calls. You can literally do anything you need to with Python. So you can definitely send an email like you can with SAS within Python itself. The first one, you can absolutely set up these notebooks to run as jobs, and there is ways that you can externally print out the log in like the workspace to like a different way, much like you would a proc print to functionality on the SAS side, where you're externally printing your log and your output to your workbench. You can do that here within Python as well, and print it out. Again, it's probably going to take some of the DBFS mount functionality, and I would certainly have to look at exactly how that would play out and how it would work. But it's very possible to print it out to some sort of a text file, that it's outputting to.
Okay, I think we have time for one more. I have noticed that most PySpark functions are just wrappers for SQL code. Have you seen cases where there isn't a SQL equivalent?
I'm not sure, honestly. Not sure off the top of my head. You are right. You're absolutely right. A lot of the PySpark stuff is, what I'm doing within PySpark can be done within Spark SQL. There's no reason why you couldn't do the exact same thing here, where you're filtering it and creating new fields based on case when statements on the SQL side. It's very, very easy to do this exact same thing. I am not sure about functionality that's not available on the Spark SQL side. I would have to look into that. I do know the initial, for me, coming from SAS and not being a big Python programmer and not being super big into Pandas, it's been a lot easier for me personally to pick up on PySpark versus on Pandas, because it makes more sense to me, having the SAS background, having knowledge around lots of different SQL languages, again, starting off with the SQL procedure in SAS. So a lot of what PySpark is doing, it makes a lot more sense to me than on the Pandas side, because I don't have as much background on the Python side. So that's why I've always kind of stuck with the PySpark rather than maybe going to Pandas or the PySpark Pandas. But that also has its limitations, because Pandas has so much functionality built into it from a data analytics and a data science perspective. There's a lot of things that PySpark can't do that Spark Pandas or Pandas can do. So yeah, I guess what I'm trying to say is I'm not entirely sure PySpark, if there's anything specifically different that you can't accomplish with like a Spark SQL. Not off the top of my head. I do not recall. I don't know.
Thanks, Derek. We appreciate your input, though. So just a reminder that all Q&A, though, and anything that we couldn't answer will be published in our Q&A page in our Confluence space after our sessions wrap. So at this point, we're going to wrap up our 6th session. Thank you so much to Derek for presenting over our last 2 sessions. Our last data camp session will start at 4 p.m. and will be on machine learning using Python and Databricks. So we're going to take just a quick 2-minute break and rejoin us in a couple of minutes. Thank you so much.